Hey, welcome back to Adventure World in Godot. In this video, we're going to continue on with our enemy Snail that we refactored in the last video and added the actor class and refactored out the player and the snail. In this video, we're going to extend the behavior of the snail. So here's my snail script, and it's extending from actor. And before, we just did a simple run, basically just runs to the left. It does have gravity, but other than that, it just runs. So what we're going to do is we're going to make it, let's close the main menu and load up a level. And in this level, we're going to edit this scene just a little bit. So let's select the tile map. We're going to erase a few blocks here, and we're going to move the snail into the hole there. So I'm going to put the snail down in here. What I'd like him to do, if we run this right now, what will happen is he will run. Whoop, the player can't see him. May need to move him a little bit closer. So the snail just runs, hits the wall, and stops. And he's still running, but he's pushed up against the wall, so he can't go anywhere. So let's move our player a little bit closer. That way we can see him right at the beginning. There we go. Alright, and so now what I'd like to do is make the snail turn around and go back and forth when he hits a wall. So to do that, let's open up our actors and let's go into the snail. We're going to need to add something here to detect that. So I could use an area 2D like we did for the player and for the snail's collision bounds. I could use another one out here to kind of detect it in front of them. But there's actually a cheaper way to do that, and by cheaper I mean more efficient code-wise. And there's something called a ray. So we have a ray cast 2D. So what you see this added like this arrow, and I'm going to move it out just so we can see it, see the beginning of it. So what I like to think of these is like if you had a dot right there and you fired it along this ray until it got to the end of the arrow, that would be a ray cast. And if it runs into anything during that time, it'll return and tell you that it hit something. So what we're going to do is we're going to go back to the transform and remove that change I made, and we're going to turn it to be in front. So I could do this a couple of ways. One, I could use this rotate tool like that and rotate it over. But what I'm going to do is actually change this cast to property. So it starts at 0, 0 right there, right? And then it goes to this position. So I'm going to just erase the Y to 0, and I'm going to just set this to, say, 10. Alright, so if I move this ray, oops, didn't mean to rotate it, I'm still on the rotate. I'm going to move tool, I'm going to scoot it out. Now, it's pointing the wrong way, so let's add a negative sign to that, right, because I want it to shoot out in front of him. And let's position it right there in front of the snail. Now I'm going to scoot it in a little bit. Well, let's leave it out here. There's a property right here called exclude parent, and that will exclude the snail's collision, but it doesn't exclude the damage area that we put around it. So that would constantly collide. And there's ways we can get around that. We could fix that, but for now let's just do this. So what I do want to do, this does look a little long, because what's going to happen is he's going to turn around as soon as he hits here, and that's actually kind of a far distance between there and the snail. So let's scoot that down a little bit. So instead of 10, let's just do like 5. That should be enough. And we'll move it just a little bit closer. Okay, that's good enough. So we're going to leave this. This will be our raycast 2D. Let's call it front, so I know it's in the front. And let's go back to our code. And in the code, what we can do is, right here, we're just going to have another if statement. We're going to say, oh, I need to make a reference to that guy, right? So on ready var front ray equals get node front ray cast 2D. Not sure why I'm not getting the help there, but that should work. And then right here I'm going to say if front ray dot, and we're going to use the is colliding property. So if you look up under classes, if you look up ray cast 2D and you look at the methods, it's got this is colliding. There's also a get collider, which tells you what it's hitting. but I don't particularly care what I'm hitting. I just care about that I'm hitting something. And so here's the is colliding. Return whether or not the closest object the ray is pointing to is colliding with the vector. And so the vector is, in our case, excuse me, the vector is this little arrow right here. Alright, so I'm going to use the is colliding, and it was a method, so I need the little parentheses there. And so I'm going to do my colon, and now this is the code that will run when it's colliding. So first let's put a debug statement here. So I'm just going to say hit. That way we know it's hitting something. So let's go ahead and try that real quick, and we'll prove that this does what we think it does. And it's not printing anything. So what's going on? Let's go back to this. We'll click on our front ray. There's a property here called enabled, and by default it's off. I'm not sure why it's off by default, but we're going to flip it on and we're going to try that again. So now we're getting tons and tons of hits because it's constantly hitting the wall. So that's great. So now what I'm going to do is let's make the snail turn around when he hits the wall. So right here, to determine which direction my snail is running, I'm using this sprite.fliph, right? And that's fine. We'll continue to use that. So what I'm going to say here is sprite.fliph equals not sprite.fliph. So if sprite.fliph is true, then it'll be false, and if it's false, then it'll be true. So it just toggles it back and forth. Alright, so what's happening here? Well, my little ray is on the left there, and it's on, and it's always on, and it's always on the left. So when the snail turns around, the picture flips, but the ray is still over here. So we need to move the ray over to this side. So what I could do this several ways, but I think the easiest way is to add a a node that we'll use as a kind of a reference to move it around. So first let's do this. Let's come down here, and there are a couple properties that can get it to turn around. So if I change this one, let's just scoot this out for a minute so we can see what's going on. If I change the rotation to 180 degrees, so that's kind of like I'm turning all the way around, that's exactly what happens. The ray turns around, right? So that's one way. So let's set that back to 0. Another way is this scale factor. So I can actually scale on the x-axis, which is this way. So I'm going to scale in a -1, and that will also flip it. But there's a difference between these, so let's add a root node. So both of these flipped it around right here, right? But what I really want to do is flip it all the way over on this side. So what I need is a node right here in the center that I can flip it over on, if that makes sense. So let's go ahead and make that. So it needs to be a node 2D because it needs to have a position. And let's drag the ray inside of that. Alright, so this node is over here at the center, and the ray is over here. Okay, so we'll call this the ray pivot. I think that's a pretty good name for it. And let's, instead of adding our rotation or scale here, let's add it up here on this ray pivot and see what happens. So I could edit him here, but I'm going to edit up here so you can see what's going on. So if I do the rotation and I rotate it, you can see I'm now rotating my my arrow, and this is roughly 180 degrees, -170. Let's just type in 180 so you can see where it's at. So this is 180 degrees, and you saw how that happened. So right here it starts at the bottom, and as it rotates, when it comes up here, it's on top. So that's less than ideal, right? So let's set this back to 0, and instead let's do scale. Now I don't think there's a thing for scale, but what I can do is grab this and drag it over and then put it on this side. So that's what happens when you scale. Okay, so here I've roughly scaled to -1 right there. Now in this case I shifted it over as I did that because of the way this drag and drop works, but you see what happened if I recenter this to 0, 0. I've actually moved it over on the other side more like I wanted it to. Alright, so let's undo this, and reset this rotation to 0. Alright, so what I want to do is and let's move this back to where I wanted it. Alright, so when what I'm wanting to do is I want to change the scale of this to -1 to flip it onto this side, and then back to 1 to flip it back to this side. So to change the sign of a number in math, what we do is we multiply by -1. So instead of flipping no, I need to still do this, because otherwise Snail will still be looking in the one direction. I need to flip that ray pivot. I also need to fix this because I changed it here. So ray pivot / front ray cast. And I also need onReady var ray pivot equals get node ray pivot. Alright, so that should be fine. And then down here I just need to say ray pivot dot scale dot x times -1. Whoops, equals ray pivot dot scale dot x times -1. There we go. So I'm going to set the set the ray pivot's scale x value to the same thing except multiply it by -1. So that'll just invert it back and forth from +1 to -1. And the way I know that this ray pivot had a scale that had an x is if you look it up the node 2D here, and then you look at scale, and you notice that scale is a vector 2, so if I click on that, I'll see that it has members x and y. It also has all this other stuff, but x is what I was interested in. Alright, so let me find back to my enemy snail. So this should flip him around, so let's give that a shot, see what happens. Alright, so now our snail is flipping back and forth, and that's great. You notice I'm just getting my hit messages. Probably don't need those anymore. The only thing I might say is if we added a variable here, so var, we won't worry about that. What I'm guessing is we're actually hitting multiple times when we hit, but that's not a big deal. Let's just leave this alone. Oh, no, it is a big deal. I know why. So when we're hitting, what's happening is our snail is building velocity. So he's getting faster and faster and faster, and he hits the wall, and he's still moving fast. And we flipped him around, so he's trying to go this way, but he's still sliding, just like our player will slide for a little bit before he turns around. So to fix that, it's a real easy fix. All we have to do is set velocity.x equals 0. And so let's watch this in action. New game. There we go. So now he's just flipping right around, and if I'd left my print statement in there, we would notice we're not getting a ton of them. Should just get one each time he hits. There we go. That's a good fix. We're going to leave the video here for now. I'm going to take this out, and in the next video we'll look at a problem that has arisen because we did this. So if we added a bush, if I move one of these bushes down in here, our snail will actually turn around when he hits the bush. We don't want that, so we'll fix that in the next one. And also we'll make him be able to stay up on a platform like this without falling down, because if we put our snail up there, he'll fall right off the platform. And that may be the behavior you want, but in our case we actually want to have him stay up on the platform. Alright, so thanks for watching, and I'll see you next time.